Hello. In this video, I'm going to talk to you about flash loans. The concept of flash loans are becoming more and more popular in the blockchain world. Flash loans are a form of unsecured loans offered by some decentralized networks like AAVE. Now, let us see a very practical use of flash loans. And trust me, in the next 10 minutes, you are going to learn flash loan in a very, very simple way. So let's get started. So look at this decentralized exchange, Uniswap. This is on Ethereum. At this point in time during the recording of this video, 1 ETH is equal to 1218 USDC. And then 1 ETH on sushiswap is 1216. So 1218 and 1216. What if I get 1 ETH and convert it into 1218 USD and then go to sushiswap and convert the USDC back to the Ether, right? So I'm going to save 2 USDC. Let me redo it. What if somebody gave it to me 1 ETH? I do not have an ETH, right? I got 1 ETH as a loan and I swapped ETH to USDC. I got 1218 USDC. And I go to sushiswap and I pay 1216 and pocket the 2 USDC and get an Ether. I return back 1 Ether with, let's say, point something as a fee back to the person or the exchange or the platform that paid me or loaned me Ether. Make sense? So this is a very basic funda of flash loan. Let's look at one more time. So you have the decentralized exchange like AAVE. AAVE is a platform which is a decentralized exchange. It gives you flash loans. It provides you that 1 Ether in order for you to do that swapping, right? So you have AAVE and you have a Solidity contract. We are going to write a Solidity contract to swap or get the loan and do the swapping. So we get the loan from AAVE, 1 ETH or how much ever you want. Swap it on Uniswap from token A to B. And then on a different exchange, doesn't have to be sushiswap, it can be on anything. You can reconvert back to A. So get loan in the form of A, swap A to B, then again on a different exchange, swap B to A, and then return the loan with a small fee. In that way, the lending pool mechanism, the pools, the decentralized platforms that lend that loan to you expect a fee in return. And all of this is done in one single transaction. So in Solidity, you're going to do the price difference. So find out the price difference between exchanges. This is a step which we are not going to look because it takes a lot of time. There might not be any differences. So we will code it or simulate it in some fashion. We'll look at it later. And then what we're going to do is get the loan from AAVE, swap token A to B, then swap B to A, and make profit with repay loan plus fee to AAVE. This is what we are going to write in Solidity. Okay, so get the loan, swap A to B, back swap B to A, make some profit, and then repay the loan plus fee. So number 2, number 3, number 4, and number 5. Again, a quick look. Flash loans are a form of uncollateralized lending mechanism that are offered by some decentralized platforms like AAVE. A flash loan encapsulates one entire transaction from borrowing to payback in one single transaction. Make sense? Now, somebody said, one Chinese philosopher said a very interesting thing. Give a man a fish and you feed him for a day. Teach him how to fish and you feed him for a lifetime. Let me teach you how you can write this Solidity contract. Very simple. I'm going to make process really simple here. And we are going to complete end to end. All right. So create a Solidity contract and inherit flash loan simple receiver base. Now you would say, what is this flash loan simple receiver base? So I go to AAVE documentation and the link of which I'm going to put it in the video description section below. So you go to this docs.aave on flash loans and read through it. I'm just doing what they have written over here. So you have Flash Loan, simple, and you need to always mandatorily implement execute operation, just as it is written here. So if you click on Flash Loan Simple, it will tell you how to request. In order to request a Flash loan, these are the input: receiver address, assets, amount, parameters, and referral code. So we are going to write this function to request the loan. And then this function execute operation is mandatory. So two functions: Flash loan simple functions to request the loan, and then execute operation so that whatever is requested is returned back. Let's do this. And you can read this. All of the things that I'm going to explain here are available here. So this is iFlash loan simple receiver. Let's see how we will implement this. Read this. This is a good documentation. All right. So I'm going to create a function to request a loan. This is the name of the function that I'm going to put it. You can have any name to this function. So this is for requesting a loan from the lending pool. Next, I'm going to use execute operation as is function because this is mandatorily required by AAVE. So this is going to perform the arbitrage. Arbitrage meaning, going from one exchange and swapping it to another exchange, and repay loan plus premium back to the lending pool from where you operated. So what is this lending pool? All right. So lending pools are in AAVE that provides you that 1 ETH or 1 USDC or 20 USDC in return of a small fee in one single transaction. Assuming that one of the steps in the Solidity contract does not complete or fail, the entire transaction is reverted back so that the lending pool does not end up losing any money. All right. So I'm going to show you a few things. So if you go to Flash, there's the same documentation, and look at the testnet addresses, which is on this file, you would be able to see these are my testnets. Okay. If you scroll down, you would see that you have to look for lending pool address provider, pool address provider AAVE. If you scroll down, this is the contract provider address pool. Let's look at this. The contract ends in 15D. You want to copy this and paste it somewhere. So pool address provider AAVE, and then in this contract, we are going to play around with USDC. So for test USDC and other coins, you have the links, but for test USDC, this is your link. So you want to copy this as well. So I copied two things: the USDC as well as pool address provider, because this is going to be needed while you create the contract. So step number 1, Flash loan simple receiver base inherited. Number 2, create a requesting function for the lending loan, a loan from the lending pool, and then use execute operation to perform the arbitrage and repay the loan. All right, few things to remember from this. So USDC. So whenever you have USDC in your wallet, you need to have. So this is, this is mainnet. I need to switch to Goerli testnet. I have 19,971 USDC. But in Solidity, you want to represent 1 USD with 6 decimal places. All right, make sure you remember that. When you're deploying the contract, you would need the pool address provider. So the pool address provider that we copied was 15D. Remember, I asked you to copy the 15D address of pool address provider. Do not forget that. And transfer 1 USD for the deployed contract. So once you have deployed your contract, which you are going to see, do not get worried. We're going to go step by step. Once you transfer 1 USD for the fees, once you have deployed the contract, you need to transfer 1 USDC as fees in order for entire thing to work. So I'm going to show you how it will work. And then this is the USDC contract address. Remember this, and then let's follow the steps, right? So let's look at it together. All right, so we got that in one slide. This is how we will create the Solidity, and these are the things to remember. So as simple steps. We are going to come back, refer to this, and then things to remember, and then we will execute the entire thing so that you know what we are doing, right? Let's get started here. So number one, I go to Solidity. This is my Solidity console and premix.ethereum.org. And then I'm going to create a new workspace. I'm going to make it default blank, and I'm going to say Flash Loan example. And please note that there's a GitHub link that will be having this code, what I'm going to show it to you here. All right, so you got the Flash Loan example. I'm going to create a first file. I'm going to call it as simple Flash Loan. In here, I'm not going to do any arbitrage. So I'll come back to this. So in this first one, I'm going to do the step number 1, step number 2, step number 3B only. I'm not going to do step number 3A in the first. I'm going to do the second one. Then we'll do the arbitrage as well. So I'm going to keep it super simple. All right. So let's do that. All right. So I'm going to get a little bit of real estate by doing like this. And let's start coding, right? So import AAVE contract Flash Loan simple receiver base.sol. Okay. And we are going to see what it's going to do. This is PoolAddressProvider, and then this is ERC20 token because I'm going to use this token, right? So 3 things: Flash Loan simple provider, iPool address because we are going to request from the lending pool, and then the ERC20. Next, we are doing a simple Flash Loan, and this is owner. So I'm going to create an owner, whoever is requesting for this contract, right? Okay, this is the constructor. So the constructor is going to be like this. Very simple. Constructor takes in the address provider, and that address provider is nothing but iPool address provider. This means that while constructing, constructor is the first function that is hit when you deploy a contract. So this is the address pool provider address that it is going to look for. So this is the address we are going to push in, and it's going to create a Flash Loan simple receiver base. That's it. Okay. Next is I'm going to create the function request loan. So let's do this how. Function request Flash Loan. And we know from our documentation, which is here, if you go to the Flash Loan simple, this is the documentation, and you would see that this is your execute operation, right? And then if you go back to the documentation, you would also see the Flash Loan simple, which gives you these parameters: receiver address, assets, amount, params, referral code with their type. And it describes what it all does. Okay, so I'm going to create the same thing: address, which is going to be the address of this contract, asset, amount, params, and referral code. Make sense? Now, this is the landing pool. So pool.flash loan simple, it's going to take in the same thing: receiver, asset, amount, params, and referral code. So I'll tell you what it does. It creates a function that takes in the address of the token, which is going to be your USDC. And how many USDC? With 6 zeros. Remember the zeros. Going back again one more time, 6 zeros. So it's going to take the address token of USDC and the amount. And this is going to convert into these parameters. So address of the contract, the token amount, the token address, USDC, and the amount, and these are blanks. And then it's going to request the pool. The pool is coming in from the iPoolAddressProvider.sol, and we are going to look at it in a few minutes. This is going to request a Flash Loan from this pool. Make sense? All it is doing is taking the tokens and assigning these 3 things: address of this contract, token, and amount. And this is requesting the pool for a loan of the amount requested. Very simple, right? This amount, it is going to request the loan from the pool. Very simple. And next, This execute operation, I am just copying it from here. Just copy it. Copy it. Do not have to worry about anything. And you can see that function pool is also here. So simple, just copy it. So I copied this execute operation, and then it's going to return true, right? This is very, very simple. It returns a Boolean. If you go in here, it returns a Boolean, right? I'm going to say return true, right? I'm doing nothing here. And then here, I'm going to say in the execute operation, you have asset, amount, and premium. It says, give me the premium. So I'm going to say, all right, no, do not worry about it. I'm going to give you the premium. The total amount that I need to pay back after the execution is amount that I requested plus the premium because it gave me that loan. And then I'm going to say approve the asset. Asset means approve the USDC to be transferred to this pool. Remember this pool where we requested the loan from and the total amount. So let's do it one more time. Request for the loan using address and token pool. It requested for the amount, and all I'm doing is sending it back to the pool. That's it. In the first one, as I said, we are not doing any arbitrage. We are requesting the loan and repaying the loan with the premium. Make sense? That's it. Okay. Okay, perfect. So this is the contract. Now let us deploy this contract. So I'm going to compile this. It's going to take some time to compile. It'll give you a couple of warnings. Ignore. You do not have to worry about it. It says that there are some unused parameters. Perfect. That is not a problem. Ignore, right? Do not worry about it. Next is go to deploy and connect with MetaMask. It's not, the remix VMs will not work because all of these addresses that it's going to be asking is for the Goerli test network. So I've connected my MetaMask 816 ending in 816 to the Goerli right here, and make sure that you have USDC. If you do not have USDC, go to this faucet staging.aave. I'm going to put this address also in the description section of the video below, and request for Ether. You can request for USDC, you can request for DAI, request. They are very generous about it. They give like 10,000 USDC for test. This is only testing, right? Don't feel so happy, right? It's only for test and doing your work. Make sense? Okay, now let's deploy. Remember, things to remember, deploy the contract with the address pool of this, right? So I'm going to deploy the contract with this address pool that we have copied. So remember, ending in 15D, I'm going to paste it over here. Ending in 15D, I say deploy. As soon as I say deploy, a pop-up comes up and it says confirm. And it is going to confirm. If you view on in Etherscan Goerli, it's going to take some time. I'm going to pause the video while it's deploying. If you look at it, I have this contract which is now deployed. I copy this, or you can also copy the contract from here and go to your MetaMask and transfer one USDC. This one USDC transfer will cover for your fees. So I say send, and I'm going to say paste the contract address ending in 5E, the contract ending in 5E, transfer one USD like this, and you would see that it's transferring. Now, what you could do is, I mean, I could have written a function over here, which would have said and given a balance of USDC, but I don't want to confuse you, all right? So what I will do is, it's sent. So we go back to your Goerli Etherscan and click on the contract. Go to ERC20 tokens, and you would see that one USDC here. So one USDC is now transferred to this contract that will help us do our flash loan. Make sense? Now, I will say request. Now, remember, I have transferred only one, but I want 5 USDCs, right? So I have transferred to this contract, not to the pool. One USDC will only serve for paying fees and other things, right? So let me now request a loan of 5 USDCs. So I go back in here. So this is the USDC token ID. So this is B43, the token ID, comma, how much I am requesting? Let me be a little greedy. I'm going to request for 20 USDCs, and I need to put 6 zeros, 1, 2, 3, 1, 2, 3. So this is 6 zeros followed 20 followed by 6 zeros. That is 20 USDC. I have on this contract only one, but I can request 20, right? So I click on this function, and it says confirm. And it's going to take some time. I can click on view on Etherscan. It's going to take some time. So I'm going to quickly recap what we are doing. So the first simple loan is requesting the loan and paying it back. I'm not doing 3A right now. We'll do 3A later. So all you would see is requesting a loan from lending pool 20 USDCs and repaying it back with premium. Make sense? Imagine this contract had 1 USDC, and now we are able to leverage 20 USDCs. So look at this. From this pool, let me show you how this pool come up. So this is the address, 15D, remember? The 15D that you put over here while deployment. And pool is 7F6. Make sense? And then from this pool, it is coming to this contract, and the contract is 5E. So look at this. The contract is ending in 25E or 625E. And you look here, 625E. So from the pool, it came to this contract with 20 USDCs. And then the contract 625E returned back to the same pool, 20.01. That 0.01 USD is the P, the premium. So this was very simple. Get the loan and repay back the loan. Let us make it more complicated. Let us add arbitrage. So what I'm going to do is I'm going to say that for a loan with some program on the Uniswap, I'm able to make 10%. So I'm without going to Uniswap and sushiswap, I'm going to say 10%. Let me show you how. So I'm going to create a new file. I'm going to say, whoops, not here. I'm going to create a new file. I'm going to say arbitrage flash loan.so. And I'm going to copy the entire simple flash loan and paste it in arbitrage. And let us see what changes we are going to make. The first one, I'm going to make an owner. So we are going to create that owner in the constructor. So I'm going to say owner equals payable. So I'm saying that whoever sends the contract or whoever deploys the contract would be the owner. And then I'm going to create a function for arbitrage. So it's a very, very simple function for arbitrage. So arbitrage USDC, whatever is my token address and whatever is the amount. That means the USDC and the amount, when it comes in, I get 10% of profit. So this is my arbitraged amount. Can you get a 10% of profit? Probably not, right? Can you get 2%? Maybe yes. But Just for the sake of our discussion, we are assuming that it's a simple math. Whatever the amount is coming in, I am taking the 10% and saying this is my arbitraged amount. And that amount I'm returning back to the owner as a profit. So arbitraged amount, imagine this as a profit. So this is change number 2. So change number 1 was the owner equals to payable. Change number 2 is the arbitraged amount. How do you do in real time using Uniswap? This arbitrage is, I'll send this link as well. It says swap exact tokens for tokens. So this is a big another solidity which I do not want to confuse you with. Remember, I mentioned at the start of the video that give a man a fish and you feed him for a day, teach him how to fish, you feed him for a lifetime. So you can go in and learn how to swap. This is a very simple thing. And for SushiSwap, it's nothing but an implementation of V2. Uniswap V2 is SushiSwap. So again, do not want to confuse you. Whatever arbitrage I'm doing, if you want to do it in real time, you can use that Uniswap protocol. At this point in time, I'm keeping it simple maths. Whatever the amount is, I'm making 10% calculation, assuming this is my profit. Make sense? And then what I'm going to do is call that function from the execute contract. That's it. 3 changes. All right. So I go to the execute operation. You see this contract now at funds requested, your logic goes here. There you go. So this is your arbitraged amount. Make sense? So it is going to call arbitrage USDC by passing on the asset and amount, and it returns the transfer. Once it is done, you also return it back to the pool. So this is how it works. I'm going to return the status, which is also a Boolean. Okay. So what happens is, again, let's run through it. Request a loan. Now I've also implemented 3A. So request a loan from the lending pool. This function is requesting the loan as in the simple flash loan. Right? Next. Sorry. Next. Perform arbitrage. So this is a small arbitrage function that assumes that whatever the amount I put in, I'm going to get 10% profit. So this is a very simple math calculation. This is the only step which does all the trick. This is transferring that token back to the owner. And then here I am calling this arbitrage, assuming you were going to call the Uniswap or whatever, right? And then this remains the same. It returns back to the pool. Very, very, very simple. Now let's deploy this contract. All of the other things are valid. That means 1 decimal places, deploy, everything remains the same, all right? So let's do this. I go back in here, compile arbitrage flash loan. It's compiled. It'll give you the error, the warning. And then you deploy using this address. You're going to copy this address and you're going to deploy using this address. So arbitrage loan, deploy. And you would see that this is deployed. It's going to take some time for this to deploy. So this is the contract. I'm going to pause it for a second here. The contract is deployed. This is the contract. This is the contract, simple flash loan. I should have renamed it to arbitrage flash loan. I'm going to rename it now, but obviously it's not going to, I have to redeploy it. I'm not going to do that. But please remember that in the GitHub, it will be arbitrage flash loan. This is the flash loan, which was deployed. The reason I know it is because it's ending in 8 dB and it's going to 8 dB. Just to avoid confusion, I'm going to remove this. So this is 8 dB. Now, exactly the same thing. I'm going to copy and go to MetaMask and transfer USDC, 1 USDC to this particular contract. So once it is done, I'm going to do the same validation. I go to the contract here. Let me make sure that this is sent. It's taking a little bit time. It's good to pause the video here. Appears that it is done. So I click on the contract, go to ERC20 tokens, and you would see that this token, this contract has 1 USDCs. Now, I'm going to do the same thing again. I'm going to request 5 USDC now, right? I have only one. One is only for transaction fee and premium, right? Do not worry about that. I'm requesting from the lending pool 5 USDCs. 1, 2, 3, 1, 2, 3. So 5 USDCs I'm requesting this time from the lending pool. So I want to confirm, and this is going to be different, right? Let's see how it is going to be different this time. So I click on view ether scan, and the transaction is still indexing. I'm going to pause the video again. Now, if you look at it, you have 5 USDCs requested from the pool. So this is the pool 5FF, and 8 dB, 58 dB is our contract, right? 58 dB is our contract. So the first step, it requests for 5 USDCs from the pool. So request 5 USDCs from the pool. This is arbitrage. So from this contract to the owner of the contract, 816, that means to my MetaMask. I go back in here, and if you look at it, look at this 0.5 USD. Remember, I had 70, 19970. You can rewind the video and look at it. I had 19970 USDCs. I transferred to the contract, but from an arbitrage perspective, I got 0.5 USDC. Look at this. This 0.5 is transferred over here. This is my 816 ending in 3816, right? This is my, and then the last one from 58 dB, the contract, it's returned to the pool with this much of premium. This is exactly how you do flash loans. I hope this is simple. This was simple explanation. Go to the GitHub, copy this code, make sure that everything remains same. Do exactly in the video, make sure you rewind the video and look at it. This is the concept of simple flash loan and arbitrage flash loan. Thank you for watching.